And now I would like to welcome on stage our very best, the beloved, the extreme, Sander Hoogendoorn, coming from Amsterdam.
Sander, hello, a seasoned developer with over 40 years of experience blending his post-agile mindset and innovative approaches to inspire teams and organizations to think again their software development.
He's a speaker and an author. He explores topics from continuous delivery to the art of elegant code, championing critical thinking and small strategic steps as the key to progress.
And the title of the speech, which I'm really looking forward to see, is called The Zen of Programming.
Yeah.
Did I pronounce your name correctly?
Sort of.
Sort of?
Sort of. Ah, Martina.
Nobody can do that outside of the Netherlands. I'll teach you.
I will do it better next time. I tried it.
Sander, the stage is all yours.
Yeah, thank you. So, let's go here. Wow, cool. So, first of all, thank you all for coming here. It's a pleasure for me to be back in Athens. I love Athens. It's one of my favorite cities in the world. So it's always good to be here. I'm going to do this really quickly because I have a lot of ground to cover, basically. And I'll also try to explain to you why that is. So this talk is called The Zen of Programming, and it's basically my personal journey throughout, well, writing code for a very, very, very long time. And I'll try to explain to you how long that period is, actually. But I'll start with the fact that, so there's basically two things that I really, really enjoy doing. Well, there's more, basically, but these are the two that really, I should wear my glasses, actually. I can't see this thing. Anyway, just do it this way. So I like to travel, as you can see in these pictures. Most of the pictures in the talk are my own. And I like to write code. And I would like to say I would like to write beautiful code. The problem with writing beautiful code is that it's all in the eye of the beholder, right? What's beautiful to me might be really ugly to you. And I'll show you some of my code, and you might say, oh, that's hideous. Or maybe you're like, oh, maybe that's better than the code I write. It could be, right? I don't know. We'll see. So the journey has been very, very long for me. And I'm going to try to show you how long. Oh, clicker doesn't work now. That's terrible. It always works. Why doesn't it work now? It's because my laptop is actually totally stuck. Should it be here now? Oh, there, it's going again. Wow. It doesn't. So I'm going to plug in the other clicker, see if that works. It probably doesn't. Oh, it doesn't. Yeah, there isn't actually. It's gone. It was here. Oh, here. Yeah, unfortunately, my laptop does not have a USB. Wait, let me try. I'm just going to start it again. We'll see what happens. Well, this is awkward. Oh yeah, let's try the other one. That's weird. Now I really should wear my glasses. Nope. No, I'll put it in here. That's fine. So let's see if we can do this thing. Oh. Yeah. Now I can't see the mouse.
Enter.
Oh God, this is terrible. It should be here already. God. Back. I don't want to do this. Like this. Yeah. And we're on again. Sorry. That's what you have right in software development. There's no AI that's going to help you out of this trouble. It's unfortunately. So it's been a very long journey. So what I'm showing you here is I was cleaning out my parents' house quite recently, and I found this thing. This is the manual for my dad's. So my dad was a mathematician, and he bought this machine called the HP25 pocket calculator, and it was programmable. And he bought this thing a long, long time ago. And this was my first touch with code. So here's the manual. I opened it up. I now have it at my home, and it says, effortless programming. That would be cool, right? Nobody can do that, but anyway, it looks great. And if you look into the manual, it actually shows you how to write code in a very, well, let's say primitive way. Because this is a long time ago. Now, my dad, being a really meticulous guy, he actually wrote down in the back of the manual when he bought this thing. So this is it, right? 24th September 1977. Anybody born before that date? Oh, I'm really the oldest guy in the room probably, right? So that's good. So anyway, this is basically when I started writing code, in 1977, 1978, right? So that's a long, long time ago. Now, in that time, I've done a lot of different things, right? As everybody who's been in this industry for a very long time. And the thing that you probably have realized if you're in software development for a long time, and is what the famous Java programmer Aristotle said. Well, he has a beard, right? So he must be a Java programmer. So it's all about learning, right? So for the things we have to learn, before we can do them, we learn by doing them. This is typically what goes very well into the mind of a software developer, right? This is what we do all the time. We tend to learn all the time. And every day we get better. And still, after like 45 years in writing code, I still think I get better at it. My colleagues sometimes debate that because I checked in actually some code earlier this week and I broke the website and they were like, no, you shouldn't have done it. I'm like, it worked on my machine. Well, they were not shipping my machine, right? So, but this is how we learn, basically. This is from Japanese martial arts, and it says there's different levels of learning, right? First, you get to the shoe level. This is where you learn from a master, right? This is just copy and do what they do, like in the Karate Kid, right? Where you have to wax on, wax off. I never know it's this way or that way. It's either way, right? So, and then he has to paint the fence, right? And you're like, why is he painting the fence? Well, he's learning the basic karate moves. He has to get them into muscle memory. My son is a drummer, he's in the room actually, and he has a lot of these movements and things just in the muscle memory, so he doesn't have to think about this stuff. And it's the same way with writing code as well, right? And then you get to the high level. This is where you see, oh, sometimes it works, sometimes it doesn't. And eventually you get to the transcend level, the re-level, where you could say, hey, I can combine this knowledge with lots of other things that come from maybe different industries or different ideas, and that I can combine into how I write my code. And that's basically what we tend to do. In the end, I think we get, and that's why this talk is called the Zen of Programming, we get to this thing that we say, well, a state of calm attentiveness in which one's actions are guided by intuition. That's basically where I got to a long time ago, is that I look at code, and what the previous speakers mentioned as well. You look at the code and you're like, doesn't feel right. And you sort of guide it by the intuition to make it better. And that's where learning works, right? The question is, how does it really work? And I found this really nice model in this book by Gerald Weinberg. Gerald Weinberg wrote like 78 books. This is one of the best knowns of it. It's called Becoming a Technical Leader. And what he did is, he was trying to learn to play pinball. You guys play pinball? I'm an old guy. I play pinball, right? I love playing pinball. But and he expected, so he went to the local bar and he said, well, I'm going to try to get better at pinball at this particular machine. And his hypothesis was that he would get better over time, and it would be like a linear process. And then he started noting down all the scores that he had, and he realized it was not very linear at all. There were these big bumps in there that he couldn't explain. And then he started thinking about, where do these bumps come from? What does that mean? What happens there? And this is what happens. He looked at all the scores, and then he started realizing that at some points he got stuck. And then he had to think of something new. And when you come up with something new, you have to try it out. The example he gives is about playing multi-ball. Now, multi-ball is a very difficult thing on a pinball machine. Have you ever had that? Like, all of a sudden, you're like 5 balls into play, and you try to keep them all in play, and then all of a sudden, they're all gone. This is a typical pattern when you play pinball, right? And what he did, he was like, I'm going to experiment with, what if I keep my eyes on one ball, and the other ones, if they pass by, fine, and I'll just ping them, but this one ball I need to keep in play, so he could continue to play. That is one of the experiments he did. And then he realized that this thing happened, is when we experiment, it doesn't always go right the first time. That's what you have with experimentation, right? It might fail, it might succeed, and you'd never know. And you go through it, and you get better. And all of a sudden, you're at the next level. And this is exactly the same with developing code. And basically, this talk is about a bunch of those, let's call it epiphanies, basically, that I had throughout my career as a developer in how to write code. So, yeah, that's what I do. And the thing is, it's not just about learning. It's also a lot of unlearning, actually. We'll learn a lot of patterns that we think we should really use, whereas when you go 2 steps down the road, you think, why did I ever do this? right? And I found this nice chart on the internet. A lot of people use it actually, but this is where I started 40 years ago. I started super simple code. I didn't know how to do anything else. And then I progressed, and then all the books came out that you all know, right? The Design Patterns book in '95, the Patterns of Enterprise Application Architecture by Fowler, the DDD book, all these books that added to my knowledge, and I started working for larger companies. And the larger the companies get, the more layers of architecture they seem to have. And the worst was when I was working for an international bank. They had 11 layers in their architecture. They could really not produce anything into production within, well, let's say 3 months, because they had to go through all of these layers with everything they did. And when I stopped working for large companies, I started to realize, what if I don't do that? What if I go back to writing super simple code? So that has become my quest, actually, to figure out how to go back to writing super simple code. And that's actually not an easy journey, right? And you're all of a sudden, you're basically like in Finding Nemo, right? Where they escape the fish tank, and they're all in plastic bags by the end of the movie, and like, okay, now what do we do? That's basically it. Well, this is a good point to introduce myself, right? I'm Sander. My main role is being an independent dad. 2 of my 3 kids are in the room, actually. The 3rd one is underway. That means he's underway here, right? It's not like that somebody... I speak a bit, I write a bit, I travel a lot, and I'm basically a lifelong programmer. I write code every day. It's just, I cannot do anything else. It's like, I'm currently the CTO for this e-commerce company called iBoot, and this is my socials and all that stuff. So, to illustrate to you that I'm a programmer, this is my name, pronounced properly in Dutch. It says Sander Hoogendoorn. Nobody can do that. Don't bother trying. It's horrible, and you speak with consumption and all stuff. But to prove to you that I'm a programmer, I am actually double object-oriented. Actually, I prefer functional programming, but it gets worse, because this is where I live. This is the view from my window in Amsterdam. It's in the Java Street. So yeah, how much more of a programmer can you be, right? So that's it. And I do some stuff in open source, but that's irrelevant for now. So yeah, well, this quest for super simple code. And it started a long, long time ago. And I've picked up stuff from people that I've worked with and that have mentored me, and that took me further down this road. So again, this is my journey, right? So there might be stuff in there that you think, totally not of value to me. That's fine, right? Please come and tell me that so I can skip it next time. But that's about it, right? And the thing is, you're never there. We are in an industry that continuously evolves. And AI is just the next step, by the way. And I like working with AI. I use AI assistants all the time, every day, with every line of code. Even I was writing code on the plane coming in yesterday, and I'm like, why doesn't my code completion work? And then I realized, wait, I'm in a plane. It doesn't work. I need to type it myself. That's terrible. It's a lot of work, right? So we get used to this stuff all the time, but it's just another layer of abstraction that we add to our work, right? That's fine. But we need to be on learning all the time. So that's what works. And then there's this. You might say, what does this have to do with the desert? This is in Jordan, I think. Yeah, it's in Jordan. But it has to do with one of my first mentors, a guy named Wim. He retired already by now. And he said to me at one point in time in 1996 or something, he said, well, programming is like this, right? It's like you imagine that you walk in the desert, and there's a thick fog. So you don't see anything besides like the first 30 centimeters. There might be a wall somewhere there. You don't know. It could be there, it could not be, and you have no idea where it is if there is one. So you might bump into it and get stuck, or you might not. I was like, huh? But this is basically what it feels to be a programmer, right? You're doing stuff, it works fine, and you check it in good, and then the pipeline fails, and you're like, what? And they have no idea. And at some point, you just get stuck, right? And you cannot do it anymore. You know, now you have AI, of course, but we didn't have it back then, right? We didn't even have the internet back then, by the way. I learned writing code from books, and from him, basically. So that's the thing. It's like the uncertainty. It's an industry with a lot of uncertainty. And nobody says that better than the great, well, he has a suit and tie, so must be an Excel programmer, but Donald Rumsfeld, he once said, in the Afghanistan war, I think, he said, well, there's the known knowns, the things we know. And there's the known unknowns. That's the stuff we know we don't know. But they're sort of fine. But then you get to the unknown unknowns. This is where it gets tough. The unknown unknowns are the things we don't know. Right? Think about that for a second. This is the stuff that we run into every day as a programmer. And you're like, why doesn't this work? I'm used to doing React components, and now all of a sudden they don't work anymore. Why doesn't this stuff like that? And it could be that you're stuck for a little bit, could be that you're stuck for days, right? And that's terrible. But this is basically it. As a result, I think, well, basically all these managers, is anybody a manager here in the room? Oh, nobody dares to admit it, of course, but it's like, well, brave, right? So, so this is the thing, right? People want to be in a predictable state. They want you to be predictable. But if you are running into a wall somewhere in the desert, somewhere into the unknown unknowns, you cannot just be that. Because there's always so much new stuff that we're doing. Otherwise, it would be just us copying code. And that would be easy, right? But that's not what it is. So we cannot talk in this industry about productivity because it doesn't exist. You cannot say, you know what, today we're going to write 2 software, or 2 stories, or even 2 story points, or even 2 lines of code, or 200 lines of code. We don't have that measure, actually, because we are always running into the unknown unknowns. So we should stop talking about productivity as a whole. And that's the thing I realized a long time ago. That's what I have against estimation, actually, because it's always hard to estimate. Once you cannot explain that to management, wow, the world changes a lot. And that's what I started to do to management, say, listen, we cannot predict this because we are not typists. It's not that every day we produce on average 100 lines of code. I actually have a negative code churn on our code bases, if I get the stuff out and it works. But this is what it is, right? A wise man once said, the code lives in our head. It doesn't live on the keyboard or on our fingertips. It's here. This is where we do the work. And we don't do that work basically from 9 to 5. And nobody actually says that better than Ken Beck. This is Ken Beck. You should know who he is, by the way, it doesn't matter. But so this is what Ken Beck said at a conference in 2003. I was in the audience, I took the picture. And he said this. He said, I'm not going to refactor the code just yet because the code doesn't know yet where it wants to go. That's deep, right? I had no idea what he meant back then. This is 2003, right? And I got it in the meantime. I do that too. I let code just sit there for a bit. If I don't like it and I don't know what to do with it, I just leave it alone for a bit. I'll go off, have a beer, go off to Athens, whatever I do, and when I come back later or go for a walk with my team or whatever, right? Anything. Listen to some music, watch some TV, read a book, and then you come back and you're like, wait, that's it. I think I should go in that direction. You have that? I have that all the time. This is basically how my mind works. And that means your mind does not really fit well in those 9 to 5 in time boxes or in 9 to 5. It's not how a programmer mind works. The programmer mind works like this, right? You get up. You probably have not much of ideas, but when you hit the shower, you get some ideas. When you're in traffic or when you're on your bicycle or whatever you do, you get ideas all the time, stuff that improves what you're doing, right? And this is how it works. And it's not like we work from 9 to 12, we type, and managers like to have us sit at our desk, right? And then you go for lunch, and then you type some more, and then you go home at 6. It's not how programming works. And we should take that into account. And that means that we do stuff very differently. And that means that in order to write proper code, in order to write the best code, the most beautiful code, your head needs to be clear. Or as clear as possible. That means it's a continuous responsibility of any programmer out there, but any creative person out there anyway, is to travel as light as possible. Meaning, to get stuff out of your head all the time. Because otherwise, I can't work, right? If my head is full, I cannot write any code in my head. That's basically how it works. But the problem is, as a developer, and we all do this, we are doing exactly what Neil says here, right? Developers are drawn to complexity like moths are to a flame, and often with the same result. We burn ourselves on complexity. And Gregor Hope says it even better. He says it at an enterprise level. I actually heard him say this last week in Berlin again. He said, excessive complexity is nature's punishment for organizations that are unable to make decisions. Take this to your manager, right? This is what actually happens. And the thing is, well, we all do this. We all work on our code with saying, hey, wait, we need to take into account this and this and this, because that might happen in the future. And we do it all the time. And we do this because, well, we're not actually doing this because it is easy, but we thought it would be easy, and it never is, because we're always running into the unknown unknowns. And we always say stuff like this, right? Oh, we might need this in the future, or eventually, or what if we want to replace this database by another at some point in time? Who said that in their career? It's terrible. I've only seen this in 40 years twice. So we have to pay attention all these words. Nobody does that, right? Replace the database. So all these ORMs that abstract away all that stuff, why are we doing that actually? Get rid of all that unnecessary complexity. I'm not saying get rid of all your ORMs, right, by the way. But so it's about might, and in the future, eventually, later, what if, at some point in time, if you hear those words and sentences, you need to get out. You need to say, wait, we're not going to do this now. We might do this later, but not now, because premature optimization, that's what you're doing then, actually causes unnecessary complexity. It's like Eberhard Wolf says, right? He says, well, we need to solve the right challenges, especially when they talk about microservices, which is funny. I had this quote in a talk last week, and he was actually in the room. And he said, well, scalability is the number one problem people solve that they actually don't have. So we all do that, right? We all solve problems that we don't have yet. We might have them in the future, but we'll see about that in the future, right? That's later. Then AI might have taken over already, and we're good. We can just sit on the beach. And it even gets worse if you take into account Hofstadter's law, because Hofstadter's law says it always takes longer than you expect, even when you take into account Hofstadter's law. That's where we are, right? This is our industry. And the thing is, and I realized basically, I had a huge burnout a long time ago, and I realized basically, all the time I have in this life, I can only spend it once. So I need to spend it on the stuff that is the most valuable to do. All the other stuff, well, let's try to get rid of that or not spend as much time on it. So every discussion I have with my team is about, do we really need this now? And if we don't do it. Ask that question all the time. And we usually put the emphasis on the word really, like, do we really need this now? I had a big discussion with my team earlier this week about something one of the guys on my team built, and he built an entirely different way of looking at things. And it got so big that the rest of the team was like, we will never be able to implement this in how we are doing it now. It's cool, but we just cannot do this. So the question was to him, and it's actually the guy with the beard in the picture, I said to him, Nafal, do we really need this now? And like, yeah, we might not. And then in that case, thank you for what you've experimented with, but we're not going to use it now. It's not what we need now. So we need to favor simplicity instead of complexity. And that is extremely hard. But you have to realize code is not a product. We're not in this industry to produce 100 lines of code. We're in this industry to produce or to actually solve problems that people and companies have. Meaning, every line of code you write is expensive. So if you can write it in less code, that's better by nature. Because you need to maintain this code, you need to test the code, you need to repair it, you need to add stuff to it later on if it's there already, etc., etc. So every code that you don't write is basically cheaper. So every time I look at code, I'm like, simple code is okay. And this is from, this is Jest code, test code for our, one of our websites. And I was looking at it, I'm like, we could do it with less code, right? And I rewrote it into this. It's less code. It does exactly the same thing, but it's less code, meaning it's better maintainable. It's easier to test the test code, etc., etc. So simpler code is always better because all the code that you don't write, you don't have to maintain. And if you don't have to maintain it, you can save your time in doing other stuff, right? This is all about the same thing, saving time that you have. So I went slowly into writing single statement functions. So I used to write really big functions, right, when I started, because everything was in one function, basically very procedural. And I started drilling it down. I'm like, wait, the smaller the functions are that I write, the more isolated they are, the easier they are to test. So I started writing single statement functions. This is typically 2 examples of my own code. And then I started to start with writing return first. Most of us write return by the end of the function, where you do a lot of stuff, and in the end, you get to the point where you want to be. But if you do it this way, just to do experiment with this, right? Just start a function by writing return, and then start to write the code, because your reasoning becomes, well, it actually reverses. And that's a very interesting thought process. You start with, what do I actually need to come out of this function? And then you take the steps to get to that point. It also helps, by the way, if you do a lot of monadic programming like this code is. And it helps to shape your habit. It helped me to start thinking about code really, really differently. So ever since I started doing this is about 12 years ago probably, I've been writing my code in any language, whether it's Java or C# or TypeScript or JavaScript or whatever language, right? So, well, those are the languages I used the most in the past decade, but and it helps you to reshape your thought process. Also, naming things. I started naming things very differently. This is very interesting, an interesting class. It comes from Spring somewhere. It's called the Abstract Annotation Config Dispatcher Servlet Initializer. You're laughing about this, right? But this is serious code. It actually has a very concise name, and that's fine. But what a lot of people do, if they would have a parameter in their signature, in the signature of their function, that is typed like this, they would call the variable also like this. This is code from a friend of mine. This is Java, and he's writing this, right? So the type is chat message context, so the variable is also chat message context. That doesn't add any value. We did this a long, long time ago when our IDEs were just text editors. Meaning, if we would go down our very long functions and need to figure out what the type is of a particular variable that we were using there, we needed to look up again and down again and stuff like that. These days, it's just hover over, or you press some shortcuts, and then you know it already. So there's no reason anymore to do this. This whole pattern should really be gone because it lengthens our code. I see a lot of code that just goes over the edge of the 120 characters that I usually use. So I started renaming things. Like, yes, these are gateways and repos, but they're just named after the thing they are working on, right? So the profile repo, the variable I use is just profiles. Or also the variables in my signature, because I write very short functions, I don't have to name this thing comment. I just can name it C, because I know it's a comment, because it says so 2 lines above where I'm writing this code. And that is changing the length of your code. The code actually becomes more, well, I would say, readable. Let's call it just readable, right? And also, one more thing, or 2 more things actually, is that the most secure code is the code you don't write. So every line of code adds a security risk. Every if statement especially creates a security issue, right? And to avoid that, you write less code. It's just an easy thing to do. Just try it. So, and another one, this is also a nice one. I see a lot of people, they leave out the commented out code, the solution you had before, and just leave it in here. So if you need to go back, this confuses the people on your team. It's hard to read, it's in dark blue. That's good, probably, but it confuses people on your team. Everybody who opens up this repo is like, why did he do this? What's with the code that is down there? Should I roll back to it, or is he still experimenting with it? Just throw it out, right? We have version control systems. They will handle that for you. You can go back in your history of your local history or your Git history and find the code snippet that you were looking for that it was before. Just throw it out. So a little thing about architecture. So this is a great building, right? This is the Colosseum in Rome. I probably should have taken a picture of the Parthenon, but this was in there already, right? So it's great architecture. I love it. It's just there. And the funny thing is, architecture is like the great Java programmer Charles Darwin. He says basically this. Well, I adapted it a little bit, right? He says, well, it's not the strongest of the architectures that survive, nor the most complex ones. It's the one that are the most adaptable. Right? We knew this already. And it's the same with code. And the funny thing was, I wrote this book in Dutch, so don't bother reading it. Nobody reads books about UML anymore, by the way. But so this is from 2003, I think. And it contained a simple architecture in there. And that architecture I still use. So this is not saying, start using my architecture. I don't care. It's saying, listen, just use one that is very applicable and very simple, and whether that's a hexagonal or whether it's an onion or whatever you do, just keep it as simple as possible. And this is ours, and we still use it actually 20 years later. So my team writes code actually that looks like this. So there's the domain always at the heart, right? So there's the entities and the value objects, and there's the repositories around it, still in the domain, and around it we have, you don't see that color actually, but we have, oh, it's in white. That doesn't really work well on a white background. So there's the process layer, it's use case logic, and there's the resources. This is typically for a microservice. And then on the bottom half, there's like, how do I get out? I get to a gateway, going into another service, into a database, wherever I go. Now this architecture has served me well over time in different platforms, different ecosystems, different languages. This is C# code from 2009, I think. It actually has the same layers, and if I delve into it, I find these patterns there, because I know how they work, and it's pretty simple. This is a repository in C#. I wrote it probably in 2008, or one in Java, in a functional style Java, actually. This is from 2015, yeah, from an insurance company I worked for. It's the same pattern. It's a repository. It's in the DDD book, right? Just write it that way. And one in Python, so it's unreadable. No, I'm just kidding. I just don't know how to read it, that's all. Where do the semicolons go? And it's got, well, anyway, there's no brackets and stuff in there. This is in TypeScript, this is more recent. But they all do the same thing. They implement the same pattern. This is basically what they do. And by the way, I shortened repository to repo, right? That's a big win. Yeah, and the funny thing is, I started working with smaller teams, right? If you have smaller teams and many repositories, as we do microservices, so we have about 150 repos, they all have the same structure. If you have a small team, we have 13 people, and I go into any of these repos, I do want to recognize the code, even if I haven't written it. And I can do that because we all follow a similar architecture. So if you have this, do this. Also, if you're on a small team, so you use a single stack, right? You can do that. It's whether you are, don't try to do one end on the front end, one end in the back, and your services in a different language and a different platform, different ecosystem, differently deployed. It makes stuff more complicated. So we removed everything from there, right? We just went to a single stack, by the way, which is ours is TypeScript on Node. So that's basically it. So if you want to read more on this architecture, it's on GitHub, but doesn't really matter. So let's continue. So what else did I pick up from history? Well, lots of stuff. It started with this. So the difference between cohesion and coupling is always a difficult one, right? So the thing is, if your components have too much coupling between themselves, they're dependent on each other. Dependencies eventually will get you into trouble. So the thing is, you should work towards higher cohesion, meaning the things that change together should be together. If you think, hey, I recognize that quote, yes, that's in the solid principles. And it's been the same throughout history, right? If you look into what the Unix philosophy said, I think in 1976, they said, well, write programs that do one thing and do that one thing really well. That is also about cohesion, right? It's always about cohesion. I was at an architecture conference in Berlin last week, and most of the talks talked about cohesion and coupling, because it's one of the most fundamental concepts in this industry. So learn about that. Bob Martin says it the same, right? He says, gather together the things that change for the same reason. That's not data, that's about code that should be together, right? So it's not about layers of repositories or layers of gateways, it's about segmenting, slicing them vertically, saying everything that's about a profile or an account, put it there. Whether that's the account gateway or the account repo, just put them together because they change together. That is basically the golden rule here. And it also means if you look into code, it's not just so much about code, actually the single responsibility about architecture, but in code you see the same. If you have this Python piece of code that is 352 lines, I immediately go into like, why are we doing this way? It's too long. It probably has too many responsibilities. As this example from my current team, this is a repo that has 5 gateways. And then you're like, And it goes into functions, and they might not look too complicated, especially not if you're used to writing promises, but still, it's like there's a lot of responsibilities in this code. It doesn't feel right? And then you get back to I call it the scout rule these days. It's not so much the boy or the girl scout rule anymore, it's the scout rule. This is it, right? This is what I tend to do with all the code, and this is a good practice. It's about leaving the campground a little bit cleaner than you found it. That, by the way, goes everything in life. Also with cleaning your house, by the way. Every little thing that you can pick up, just pick it up. It's gone. And that's the same with code. If I look in code and I'm like, this has some depth in there and it doesn't feel too right, I should probably do some work on this. And I rewrite it. That's what I do. And it helps to keep your code bases clean and solid, basically. Not so much in the solid principles, but just solid. And the thing is, you learn to do this by intuition. Again, the intuition, right? The intuition that you build up over time in this industry is actually fundamental to how you do your work. So yeah, use that intuition to do it. And then we get to testing. So I have a long piece normally about unit testing in this talk, but you all do that already, right? Who's written unit tests this week? That's not good, I can tell you, right? That should be almost everybody. Well, that might be that there are people in the room that haven't written any code this week, but the thing is, testing your code is fundamental to, well, getting some speed in what you do. And I'm not going to talk about unit testing today, I'm actually skipping that part, but I do want to talk about testing as a design technique. Gerald Weinberg says, design is the progressive elimination of ambiguity, right? Just remove the ambiguity from your code. And every code statement that you write contains ambiguity. Every if statement that you write causes multiple scenarios in your code. And now if you're in a distributed architecture, it gets a lot worse, by the way, and even worse. So having tests for all that stuff is just good, because you can run them in the pipeline, and you know that when you push your code to production, it's going to work. Or at least it does technically what it should do, right? So yes, you do need to write all these tests. And the thing that I learned over time is actually coherent with what Dave Farley says, the author of the Continuous Delivery book. He says, well, start with assuming that we're wrong, not that we're right. I have a lot of people in teams that write some code, and they say, well, that should work. You've said that too, right? I've said it too. I have a guy on my team who particularly says that every day. Like, yeah, it should work. And I'm like, how do you know? And then, well, I tried it. So do you have a test for it? No, I still need to write it. It's funny because I have a guy from Argentina on my team, and his English is quite good, but he does have this little Argentinian dialect in it, right? And he says like, I still need to add some courage. I'm like, why do you need courage? And he said, no, coverage. Huh? Oh, okay. It's pretty much the same thing, actually, right? It's about the courage to check stuff in and to release it to production without, well, feeling insecure about it. And that's what it actually does. It's a design technique that helps you create your code and put it out better than you thought you would without writing the code, or that you can without writing the code. And these are some of my own tests. And what I do is I start writing from the statement, start writing all the things that can go wrong. I write them down into a test. And only if I tested all of those, I, in the bottom, test the one that is actually the code that I want to have, the behavior that I want to have for my code, right? It's just a technique I use to do this. So this is also some of these epiphanies that I had, right? Just doing it. And the reason is that when you do this, and I've been doing this for a long time, especially if you do open source project, it is vital to have everything tested, because other people are using that code, and you don't know who is using it. So every addition to that code base needs to be properly tested, because we might break other people's code, and you don't want to do that. So it helps you to code with confidence. By the way, the reason this programmer is praying for his code work is, of course, because he works in light mode. It's not, you don't do that, right? It's just undone. So, and by the way, remember that test code is code too, so the scout rule is valid here as well, right? You need to keep the campground cleaner here as well, because this is also code that you're going to maintain for a very, very long time. So next thing, I suppose, right? We need to talk about quality built in. This is an interesting quote from Edward Deming, who's a genius, by the way, but he says, eliminate the need for massive inspection by building quality into the product. Again, this is about testing and automating those tests. As a result, if you do that, you probably all do pull requests, right? And code reviews and stuff like that. Yeah? Do you like it? Say no, say no. You know why? Because they're too late. And you're like, what? They're too late? Do you do them on the same day that you check in your code? No, right? They're usually happening a day later, after the weekend, next week, because somebody's on holiday or ill. That means there's a lot of delay in there. And to get that delay out of there, you could say, what if we don't do pull requests? Yeah, you're laughing, but we don't do it, actually. So it's it's unimaginable for a lot of people. You're like, what is this dude talking about? It gets worse. We don't do code reviews. What we do is this thing called trunk-based development. We don't branch either. We just write code, check it in. And we have everything tested. We have 17 layers of testing in there, right? So that means if I check in my code, I've tested locally already, when it gets through the pipeline, it goes to production automatically. And we don't branch. The consequence of that is that people say, no, you cannot do that because that requires discipline. Because the thing is, the longer I wait with checking in my code, the longer the delta is, the bigger the delta is between the code that's on the main branch and the code that I have checked out. Meaning, merging it back into whatever is there becomes more difficult the longer you wait, especially if other people are doing the same thing. So, what if you check in your code all the time? What if you just write very small things in single-line functions and you check it in all the time? Yes, that requires discipline. That's what she says, right? You want to everybody commit to master main, basically, right? But yes, what's the problem? That means one has to be very disciplined by coding and giving a lot of thought on when and what to commit. Yeah, that's exactly what you want to achieve. This is why trunk-based development works in a lot of environments. It doesn't work well in very highly regulated environments like banks and pharmacy, whatever, but in most cases, it works pretty much fine, right? So it gets more complex. Software development is complex. And Edsger Dijkstra was right about this. He said this in 1984. He said, the programmer has to think, or to be able to think in terms of conceptual hierarchies that are much deeper than a single mind ever needed to face before. We are in the most complex industry in the world. Forget landing rockets in something, right? Forget building cars or going to the moon or building a pacemaker. That's all software, by the way, right? We do that. It's us. And if you're a small company and this is your stack, and this is not made up, this is real. This is from a scale-up that I worked for, and they had all this because they're building embedded software, web, everything. It broke, right? They couldn't maintain this. It was too complicated because they had too many dependencies. And dependencies will kill you all the time. This is where we always go wrong. This is why you always need to renovate to get to the latest versions of your dependencies. Stuff like that. And this is also where the 1990 rule is valid. This is an interesting one. Right? Tom Cargill said the first 90% of the code accounts for the first 90% of the development time. Sure. And then he says the remaining 10% of the code accounts for the other 90% of the development time. We always go wrong here, and that's always because of dependencies. Dependencies make us late all the time. And also, it made me realize that there's so much in this industry that I have no idea about. You cannot know everything anymore. I used to in 1984, 1987, whatever. The world was simple back then. There was no internet, there was no web, there was no browser. We just wrote desktop applications, that's it. And they ran on a local machine on somebody's computer in the department. That's when the world was still nice to me. But I can't do that anymore. Meaning, the smallest unit in this industry of work is not the individual, right? If you have individual KPIs, go talk to your manager. Team is the smallest unit of ownership in the company, in code, right? We as a team own the code. This is what we do. The question is, so what do? Well, we learn by doing. That's still coming back to Aristotle at the start of the slide, right? So the old ancient Greeks were always right. Well, not always, but they were right a lot, actually. So, that means you need to go into experimentation mode, meaning you do tests, and they might fail, right? By the way, if you don't make decisions, you're also screwed. You need to make decisions. You need to choose often, right? And that's the thing. So Jeff Bezos then says, well, most large organizations, they do embrace the idea of invention and experimentation, but they're not willing to suffer the string of failed experiments. This is what you need to think to yourself is, am I allowed to fail? Can I run an experiment on something new that I want to try out or that should be probably good for my company, but what if it fails? Do you get punished? Or are you like, okay, good experiment, let's continue? And we went to do this. I'll show you that really quickly. So here's the D-Hawk. He is the CEO, he was the CEO of ISA, and he said, simple, clear purpose and principles give rise to complex and intelligent behavior. I suppose that's what you want, right? Complex rules and regulations give rise to simple and stupid behavior. This is what a lot of managers do. Not all, by the way, but, and then he says, you need to simplify to amplify, and that's the goal. This is a crossroads near where I live in Amsterdam. They removed the traffic lights here. Not because they weren't necessary, but because they did an experiment. They were like, what if we remove them? What will people do? And you know what they do? Because I cycle about this thing almost every day. They communicate. They start to communicate. You have to check the other people who are on the crossroad to see what they're doing. And then you're like, oh yeah, I can see from the way you look that I can go first, or you can go first, right? In Amsterdam, that's, by the way, very complicated because everybody goes first. Except, especially when you drive BMW, then you just wait for the BMW to pass by, right? So that's how it works. But cyclists, pedestrians, they all go ahead. So you need to check. You need to communicate. You cannot do stuff on your own anymore. And that's where we went with my team. We start saying this. Perfection is achieved, not when there's nothing more to add, but when there's nothing left to take away. We removed all that stuff from my team. Here's my team, and this is what we don't do or don't do, right? We don't do Scrum. I don't like Scrum, actually, too much. Although I'm speaking next week at the Scrum Day Europe. I have no idea how I got there, but it's terrible. It's like scary stuff to me. So we don't do Kanban either. Most people say, if you do Scrum, you must do Kanban. Nope. We don't do sprints. We have no retros. We do less stand-ups. We had one today, but I missed it because it's now, actually. We don't have a Scrum Master or a PO. We don't have stories. We have estimates, but only a very high ballpark figure, like probably 3 months. That's it. More we don't know. We have this very simple architecture. We don't branch. We don't do pull requests. And we don't blame. And that's an important one. We trust the people to do their utter best in my team. Whether you're junior, senior, AI, doesn't matter, right? We all expect them to do the best. And they do. And then we talk to each other, and we can do this a little bit better, right? So this is how we do roll, right? We do a lot of this stuff, like mob programming, what you see here, or ensemble programming, if you quote it nicely. Pair programming, we do that a lot. We do event storming sessions to get the ideas across and the processes. We have lean coffee sessions every week, where we just put some ideas that people want to talk about, and we discuss them with the team. They might take an hour if nobody has anything interesting. They could also take up the whole afternoon, and that's fine. It's where we learn, and learning is the most important one. We also work in this thing called micro teams. I started quoting that. It's actually, the people on my teams work in different setups all the time. Not because I tell them to, but because they want to, and they want to learn from each other. So this is 3 developers, 2 backend and a front-end developer. This is 2 developers and a tester. You recognize the tester, he's standing. Yeah, you don't want to be a tester, right? Or this is also nice, 2 Java developers. They have beards, right? So, yep. Or this is an architect and a developer. The developer already knows it's not going to work. The architect is still praying for it. That's basically their job, right? Praying for stuff to work. So last thing. This is my mom, the one on the left. And I'm having dinner with her in a small town, and we just got back from a trip from Italy, and I showed her the pictures, and she said, why didn't we, and she meant my dad and me, why didn't we ever go to Italy? They did, by the way, just once. And I said, well, you went to the same campsite in France for 25, 30 years. I don't know exactly how much it is, quite a lot, actually. They went to the same campsite. And the good thing is, there's nothing wrong with it. It's the way they wanted to live their life. Basically, it's their choice. They didn't want to go to Italy. They, in hindsight, might have wanted, but that's the thing. And the thing is, there's different kinds of people in the world, and we need them both in software development. There's the people that want to ignite that change all the time, people like me. You don't want 20 people like me in a team, right? It doesn't really work. You also need the other kind of people that go to the same campsite in France every year and do the repetitive work and do the 9-to-5 crunching because they just like doing that. That's fine. So some people do like to change, some don't. But if you are that one person that wants to ignite the change in your company, don't wait for others to do that, right? It's you. You have to do that. You have to ignite that change. There's nobody else that's going to do it for you. So if you want to start a small experiment in your company, just do it, right? Go ahead and do it. Because you should never be afraid of asking stupid questions. I do that all the time. And that's because I don't know everything. And everybody in my team knows we don't know everything. And that's a good thing. So you can never stop learning. By the way, simplify to amplify. And also, one of the most important things is, this is also the most fun industry in the world, right? So I wouldn't know what to do else if I weren't a software developer. My youngest son once asked me, he said, Dad, what would you do if you were not a software developer and you couldn't write code? I said, well, I would learn to write code as soon as I could. That's basically my line. Oh, by the way, if everything else fails, you just remove the node modules and you do an npm install and you're good. One more thing, and then I'm gone. Take your mom out to dinner more often before you cannot do that anymore. Thank you, and enjoy the rest of the conference.
That was an excellent talk.
Thank you.
Okay.
And
We have some questions for you.
Oh,
Let's see. We need to bring that also.
that's a long question.
Yeah.
You're actually going to read it?
So, thank you for your insights. While I understand that precise time estimation in programming can be challenging due to the complexities and uncertainties involved, how can we find the balance between providing reasonable time estimates for stakeholders and focusing on producing high-quality, maintainable code? Are there strategies or practices you found effective for managing this tension?
nice one.
Yeah, that's a very good and interesting question. So the main strategy I have with companies, explain to them that it's very hard in this industry to do proper estimation, right? You are not in an industry that stuff is repeatable yet, right? We might get there eventually in like 50 years, or maybe if AI does it a little bit sooner, but not too much sooner. So we don't know, and it's okay to not know. That means if you give up highly detailed estimates, they're always wrong, or they could be right if you're lucky, or if you're doing the same thing for over 30 years. I worked with a team of COBOL developers. They were very good at estimating how much time stuff needed, because they were doing the same thing for 30 years. Most of us are not. Meaning we cannot estimate at this low level. That means you estimate at a much higher level, at a higher level of abstraction, where stuff is like big. Like you can say, well, this probably takes us about 3 months. Nobody will actually complain if then it takes 3.5 months. The other strategy is that if you estimate, you have to take into account that managers will do this. You say, it's probably going to take me 2 weeks. And then the manager says, oh, so you need 2 weeks. That's not what estimation means. Estimation means, I think on average, it might take us 2 weeks. That means it could also be 1 week, very likely not, but it could also be 3 or 4 weeks. And they have to realize that that is what estimation means, right? So the best strategy about this is to educate management. That's the best you can do.
All right. Do you have time for one more? Yeah.
Yes.
Let's go for one more. So you mentioned the concept of lifelong learning in programming. How do you recommend balancing this with the constant pressure to deliver on tight deadlines in the software industry?
Yeah. That's a tough one. So there's always a balance between taking the time to learn, and learning costs time, right? But learning is also very effective in the future, right? So actually for companies or organizations, the fact that you want to learn, they should actually value that very highly, because they're much more, you as an employee are much more valid if you continuously learn. Whereas people who don't learn, they get outdated really soon, especially in our industry, right? That means your knowledge will downgrade. I think the half-time of knowledge in the industry is about 3 years. That means half of your knowledge will be wasted after 3 years' time. That is really, really short, right? That means if you don't learn, then you can only do the things that you did 3 years ago. For a company, you become less valuable. So you actually should understand, again, well, it's again about education of probably the managerial people in the company to understand that learning is vital to the company as a whole. And yes, that it costs time.
Awesome.
Perfect. And we have a lot of questions for you.
Oh.
I guess you're ready. The third one, you mentioned the concept of...
Yeah, that's one.
Yeah.
You mentioned the concept of lifelong...
No, that's
Well,
one I asked. So
For
last
Sander,
one. Yeah.
what is 3 key tips for a junior developer? What do you suggest for developers that try to find a job right now in the current market? That's interesting.
Yeah. So junior developers have one big plus over highly senior developers, and I'm not saying all highly senior developers. So to give you an idea, I only hire junior people into my team. And the reason for it is twofold, actually. So they are eager learners, and they learn very fast, That's my experience, but I've only been hiring people for years, so might be my personal. And the other thing is, if you hire very senior people in a good rolling team, a team that's well on the way, that knows how to work together, that is very comfortable in collaborating, and you hire somebody in from the outside who is very senior, what will happen quite often is that they want to change the way you're working. A little bit, that's fine, right? And if they do it over time, but I've seen a lot of situations, examples, companies, where they hired senior people that wanted to change everything you did. We were well on the way in a microservices architecture in 2014 at this insurance company. They hired 2 very senior Java developers, well-respected developers, good developers, but they had a very different way of working. And they started, well, sort of battling the way that we were working at, in which we were quite successful. So that's why I prefer hiring junior developers in my teams, because they're eager learners and they're much easier, they fit in much easier into an existing team. So as a junior developer, right, make sure that you make people understand where you apply, that you are this eager learner, and that you're eager to fit in, and that you're eager to, well, to grow really rapidly, because you have that opportunity and you have that ability to do that.
Great.
Great, perfect. So another last question. You mentioned how often you get your mom out and everyone should do that. How often do your kids get you out?
How often do my kids do what?
How often do your kids take you out for dinner?
Oh, that's a good question.
Do you want me to ask them?
How often do we do that?
Never?
They don't want to answer. We actually went out to dinner last night, so.
Perfect. So thank you so much.
It's been great to have you. Thanks a lot.